everybody, and welcome to Lesson 4.3, Inequalities in One Triangle. Today we're going to look at some special properties that happen within single triangles and how their angles and sides relate. Before we can do that, we need to review a really quick property of inequality, and that's the comparison property of inequality. And what it says is that if A equals B plus C and C is positive, then A must be greater than B, always. And we're going to prove it just really quickly. I am going to start off with just one of my givens. C is greater than 0. And with this given, I'm going to add B to both sides, which is my addition property of inequality. Now, I can drop that 0, right? I don't really need it. So we could just erase out that piece. So I have B plus C is greater than B. Good place to start. Well, my other given is that A equals B plus C, right? That's my other given. So I can use substitution. Right here, I've got B plus C and B plus C. Well, I can now say that A itself is greater than B by substitution. And we've proven it. We have proven that A is greater than B. End of proof. We're going to use this property several times to prove lots of these fun inequality theorems about triangles. The first is the corollary to the exterior angle theorem of a triangle. And remember, our exterior angle theorem said that this angle equals these two angles added together. So it would make sense that x must therefore be greater than both of those angles, right? If it's equal to their sum, that means x itself must be bigger than both. So if angle 1 is an exterior angle with 2 and 3 as its remote interior angles, okay, I'm going to draw that real quick, right? Let's do this, where I have angle 1 and then 2 and 3. Then the measure of angle 1 must be greater than the measure of angle 2, and the measure of angle 1 must also be greater than the measure of angle 3. So we are going to prove that now. Okay, so I'm given angle 1 is an exterior angle with angle 2, angle 3 as remote interior angles. That's my given. Well, we have a wonderful theorem about this, the exterior angle theorem, that basically says that the measure of angle 1 must equal the measure of angle 2 plus the measure of angle 3, right? That's the exterior angle theorem. Okay, now in a triangle, all of our degrees have to be positive measurements. So I can say that the measure of angle 2 must be greater than 0 and the measure of angle 3 must be greater than 0 because all measures in a triangle are greater than 0, right? That's just basics. We don't have negative angles. So I can then say, using the comparison property of inequality, that the measure of angle 1 must be, ooh, I did that backwards. Let's try that again, guys. Where's my eraser? There it is. Please erase, or not. The measure of angle 1 must be greater than the measure of angle 2, and the measure of angle 1 must be greater than the measure of angle 3 by the comparison property of inequality. we're done with the proof. So we can then write inequalities within our triangles ourselves. Within a triangle, if two sides of the triangle are not congruent, then the longer side is opposite the larger angle. So for example here, if side AC is longer than side AB, well, AC is across from angle B, and AB is across from angle C. So my longer side, AC, is across from the larger angle, and the shorter side is across from the shorter angle. Cool. So this also works in reverse. If the measure of angle B is greater than the measure of angle C, then AC would also be greater than AB. So there you go. It's a pretty easy thing to see. So we can even take this one step further, and there's a theorem out there that says that the sides of our triangles added together have to always add together to be larger than the third side. And y'all actually discovered this in construction, not 5-2, but 3-2. When you tried to construct a triangle and the sides weren't long enough and your arcs weren't crossing and it was very frustrating, you discovered that two sides of a triangle must always be longer together than the third side. So here, side AB plus BC has to be greater than AC, AB plus AC has to be greater than BC, and AC plus BC has to be greater than AB. In the diagram below, these segment lengths wouldn't form a triangle because side length DF, which was 2.01, plus GE, which was 2.00, those added together were not greater than 4.47. They just couldn't reach together to make a triangle. So that's what we're always looking for when we're looking at triangles. So I want you guys now to go try the MML exercises. They're pretty easy. I think you'll have no trouble with them, but definitely if you get stuck, use the help. Thank you guys very much and have a great day.